Okay, so now that we know a little bit about dot plots and stem plots and using those for small data sets, we're going to take a look at histograms. Now this kind of looks like our bar charts that we talked about when we looked at categorical data, but these are going to be specific to quantitative data. So we use histograms in order to communicate information about large data sets. And although we get a better picture of the entirety of the distribution, we lose information about the individual observations. And I'm going to just shorthand a little here. And since the data is now being given in terms of these bins or intervals, our summary statistics will be given in intervals, using the words between to denote that location of that statistic. So we're going to use words like approximately and between to account for this uncertainty. And so if you've never seen a histogram before, these are the elements of a well-constructed histogram. You need a title, of course. Your x-axis are going to be the bins or those intervals. So for example, the age category between 0 and 10, then 11 and 20, then 21 and 30, etc. The y-axis is going to be in terms of frequency. And thinking back to categorical data, frequency is the number of times that observation occurs, the counts. So I'm counting how many observations are right here between 15 and 20. How many observations are between 20 and 25? And then lastly, if there are no observations for a bin, you leave the bin blank, which is going to indicate a gap. We don't eliminate bins. And we do this, we don't eliminate these missing data pieces because one, we don't want to give misleading data. But two, it's not that they're, this weird idea of like 0 versus none, like there are 0 observations there, so there are no observations there. That'll just help us to identify our unusual features. So let's take a look at an example histogram here. And the graph below represents results of a survey in which students stated the number of minutes they'd spent watching TV the previous day. Use the histogram to describe the distribution. Alright, so you can see here, just off the bat, I can see, I'm pretty much skewed left. I see a peak right here at 150 and 179 minutes, but the median and the range. So this is where it gets a little spicy with histograms, is that our approach to them is just slightly different. Again, because of this uncertainty, we gotta figure it out. So let's figure out how many total observations there are in this histogram. So I'm actually just gonna count here. So this bar right here tells me there are 3 observations between 0 and 29. There's 1 observation between 30 and 59. 4 between 60 and 89, 2 here, 6, and 7. So what I'm going to do is I'm going to sum these up here. So 4 plus 4 plus 2 plus 6 plus 7. I got that there should be 23 observations, 23 students' watch times that are being reported. Now, you notice I have an n here, so I can actually now use this n to find the median or the second quartile. So n plus 1 will be 24. And 24 divided by 2 will give me 12. Oh, so the median's got to be right here at 12. Nope. Hopefully you're starting to get into the practice of recognizing this isn't the 12th, the value of 12. This is the 12th observation. So if this is the 12th observation at the median, I need to figure out where that 12th observation is. So let's check. Well, 3 observations are here. That's not 12. In totality, cumulatively, 3 plus 1 is 4. That's still not 12. Well, here underneath 89 minutes, I have 3 plus 1 plus 4, that's now 8, still not 12, plus another 2, now we're at 10, so if 10 plus 6, 16, so this bar right here is going to represent the 10th observation or less. Here's going to be the 16th observation or less. So what happens now is to find the 12th observation, I need to find which interval it's in, and it looks like the median is going to be in this interval here. Now, I don't know what the value of the median is. I don't know if it's 120 or if it's 149. I just know it's between 120 and 149. And now we're going to take a similar approach to the range. Now, there are several ways to do the range here with a histogram. So the first way is that you can assume that it's the smallest amounts of the highest and the lowest, meaning that I could do, I guess I should pick a different color. Like, I could do 150 and 0, right? The lowest of both of these bars. Or I could assume it's the highest, 179 and 29. But again, since this is a histogram, I've lost individual observations. I actually don't know. So I'm going to assume it's the highest, and I'm going to assume it's the lowest, and I'm going to say the range would not exceed those values, because regardless of whatever those values are, I don't know them, but I know it's not going to exceed a maximum of 179, and it's not going to be below a minimum of 0. So my range here is going to be approximately 179 minus 0. So we're going to say our range is no more than 179 minutes, right? The total watch time varies between 0 and 179 minutes. So that's kind of the idea there of finding the range and the median from a histogram. Now, sometimes you'll be given summary statistics, so you can actually find the quartiles, or if you are given summary statistics, you can check if there's outliers. But most times we're going to follow, when we cuss about this distribution, we'll still do median, anything unusual, the shape, and then for our measure of spread here, we'll do range. And again, unless we have those specific values here. So here is what we need to do now. We need to describe our distribution. So let's start with the measure of center. So the median TV watch time for this group of students has a median somewhere between, and we said 120 and 149 minutes, as well as a range that is no more than 179 minutes. And see my wiggle words, like between, no more than, somewhere. You could use approximately if you wanted to. But again, you're giving that wiggle room. I don't know any definitive information about this data set. I just know these intervals. The distribution of TV watch times appears to be, and I could say unimodal and slightly skewed left with, so notice there the shape, if you're going to claim there's a peak in the data, you can also use that for your unusual, but you have to list that peak specifically. I can't just say there is a peak, like that's not going to help me. Where is the peak? So here I see the distribution of TV watch times, sorry, I forget I'm flipped. It's slightly skewed to the left. And there is a peak in the data, so I'm going to say with a large cluster of data between 150 and 179 minutes. All right, there we go. So now I'm going to just self-check here. Did I give context? Yep, I said TV watch time. Did I talk about a center? Yep, I said a median between 120 and 149. Did I talk about anything unusual? Well, I didn't see any gaps or outliers, but I did see a large cluster of data there at the 150 and 179. Did I mention the shape? I did say that it appears unimodal and slightly skewed left. And did I talk about the spread? Yes, I said I have a range of no more than. So there's all the wiggle room you need there. So this is just the idea of histograms. And then you can also find the proportion of data. So for example, a follow-up question I could ask you is to find the proportion of data that is less than 119 minutes, right? Or less than 120 minutes. And so then I would count all those observations. So that would be 3 plus 1 plus 4 plus 2 out of 23 total. And so that would give me 10 out of 23. Right, see, there's follow-up questions as well to things that could be asked with the histogram. So what I need you to do now, in true Pinto fashion, is I'm going to need you to pause the video. And I'm going to need you to work with a partner, or if you're watching this solo, but you're going to work through these example questions. So here's another question, again, with some of those summary statistics. And then on the back here, there's some additional multiple choice questions for you to practice using histograms. So go ahead and pause the video, use and reference your notes, and just do your best. It's going to be okay. So we'll come back together, whole group, to review the answers. Alrighty, so hopefully not too complicated there. Here we're skewed right, so we should recognize the median is less than the mean. And then based on our outlier rule, any observation greater than 9.5 siblings would be considered an outlier. So here at 9.5, I see that I have 2 outliers there. To find the median here, we do our good old n+1, and I look in between the 40th and 41st observations. I can see that my tail is to the right, so I should be skewed right, which again tells me that the mean should be greater than the median. And to interpret the standard deviation is that on average, the number of siblings differs from the mean by about 2.535 siblings. And then just to check your work here on the multiple choice, we should have gotten bimodal, one cluster, another cluster, and then a range. And then here, this one's kind of weird. It's not very common to find the IQR from the histogram, but totally possible. So we noticed we did not talk about constructing the histograms. So just a quick note on that is that you would Categorize your data based on the interval. So once you decide the intervals, you're going to take the frequency of your data to determine how many of those observations fall within that interval there. And then once you have that total frequency, kind of like a dot plot, then we're going to create these bars to recognize how many are in that interval. And then from there, you just kind of start drawing the bars. Now, it's very unlikely they're going to ask you to do this on the AP exam. So in true Pinto fashion, we're going to do some delta math practice and constructing histograms. And you're going to see how terrible it is to do it by hand. But all good. We're going to keep working hard together. And so now we can do dot plots, stem plots, and histograms, and we can describe quantitative data. So in the next lesson, we're going to talk about that 5-number summary and box plots, and we'll be wrapping up the first half of Unit 1. So stay tuned for more.